Hello, Amiga artists and coders. Um, I had a pretty zen painting session and made an example cloud. And I started with the demo's background color, um, shaded it up to almost white, made a spread and a range. Uh, it would have been nice to record how I made the cloud, but I'm not entirely happy with it, and it would take time. In summary, these are the brushes I made for spraying out the cloud. And then I used these masks to sort of even out the bottom and shade the bottom of the cloud. And then applying these masks with smear to give it a sort of dithered look. So this is the bob that I'm going to use as an example. I would have liked to, since everything else in the demo is metal, I would have liked to make some metal clouds in various sizes. And I probably will later on because it fits more with the theme of the demo. I'm not entirely sure that this palette is the optimal one, but it's sort of subdued and should fit in the background. So I'm going to go with that. So I wanted to talk about the conversion of bobs. Just like we did when we did the font, if you remember, then we had a whole picture that we converted at once. It would have been murder to cut out all the bobs manually. Sorry. And why not? Load. So if we add more clouds, then one normal way of easily adding them to a picture for conversion is to put them one under each other, packed, and then you convert the whole rectangle at least, and you could even supply some coordinates for it. For a game, for example, you would utilize every pixel in the bitmap and pack them as tightly as you could, and then you'd cut them out, sort of unpack them and space them out like the font that we made for shifting, which is the major issue, or major problem to solve, rather. So when we cut this out, we should align ourselves with the leftmost pixel and the topmost pixel. But then we would, as you can see, these, as I mentioned before, these word boundaries, these vertical lines, tell us how far we have to go to include the last word of bitmap data. So I've just overstepped that last vertical line, and this will give us an extra word of spacing on the right of the bob. Okay, so this will allow us to shift the cloud between 0 and 15 pixels within the bitmap words when we blit it on screen later. I'm going to see if I can persuade the emulator to not give me all caps, and we're going to call this 100 by, actually that would be 112, right? Rounded up to the nearest 16 pixel boundary. And call it raw, and we want to do this interleaved. There's no reason really to have it interleaved, but since the bit planes on screen themselves are interleaved, it's simpler to just start a single blit for all the three bit planes. We also want the masks. So we're going to do them. It's called outline here. And I'm going to grab the colors. There we go again. Cloud copper S. And let's do the copper. And save that. And that should give us the files we need. All right. So the first thing to do, obviously, is to include the cloud. And I'm going to put it where the other stuff is. Maybe after the font. It's a good place. Just going to grab that. And I suppose I'm deviating a bit from the .raw with this font here, but it's a convention that I use. So that's our cloud. I wanted to talk a little bit about Playfield priority and things like that. Could really wait until the next tutorial, next episode, but I'm gonna have a look at the copper anyway. So one of the things is sprite priorities, and the priorities are correctly set for what we want right now. We want the sprite star field behind everything, and that's this word here. So that would so you would change this to decimal 36 to put all the sprites in front, and you would use a third value to put the sprites in between the two play fields. You can also put sprites individually in front of or in back of uh, individual play fields. So there are a lot of bits to set here. Those are just two common values. Here's the scroll register. We haven't used it yet. We scrolled the scroll text with a blitter so far, but we could use this to scroll the clouds if we decide that we want that. And then you would be able to scroll the playfields individually. So each playfield has a nibble containing the shift value from 0 to 15. So if you wanted to scroll one playfield 5 pixels, you would do that. And if you wanted to scroll the other, offset the other playfield by 5 pixels, you'd swap the nibbles like that. So this would contain a value from 0 to f, and so could this. But for now, we're not going to use the scroll registers. I just wanted to mention these. So that leaves blitting it to the screen. If you remember, in our init code, we did the screen clear for our sky, and we will have to invent some method of addressing this playfield and put the cloud wherever we want it. And also I will mention some different minterms for use with blitting bobs. We already have a blitter routine, so why not have a look at that? I'm just going to search for BlitCon. So this is the character plot routine for the font for the scroller. So we could just grab the last chunk of this and make a routine called plot cloud, perhaps plot cloud. Now we have a stack move here that I didn't copy, so let's grab that. And we also need this. No use reinventing the wheel when you can reuse code. We will have to change some things though. I'm going to put a bookmark here and go down to the bottom because if I remember correctly, we still have our Minturn table here. So whenever you're blitting anything, you have to decide on the channels. So which channels are you going to use for what? So I'm going to copy this, make a new blit. By the way, I'd like to mention that I'm just typing these notes freely in assembler source, and that's normally not possible. It is possible because of this compiler directive end. So anything below this is a notes area. I wanted to mention this because it may cause an incompatibility with your assembler so that you may have to simply strip the source of everything that's below this end command. Most assembler reasonably would have a similar directive. So RTFM time. If you need to. So plot cloud, we're going to enable some channels. In fact, we're going to enable all of them. We could blit this cloud with an OR minterm. That is to say, you would, whatever was on the screen would be combined with the cloud that you plot. Or we could just copy the cloud, and then wherever you touch the bitmap, that area will be overwritten by the cloud graphic. So the OR minterm would be DFC, and the copy minterm would be 9F0 if you set up the channels the way I do. So depending on how we map the channels for the blitter, the minterm will be affected. The 9 would still, no, it wouldn't. The 9 would change to another number, for example, I don't know, A or 5 or something, I don't know. And the D would change if you swap the channels around. What I'm going to show you is the standard way of putting the channels, which is the optimal way. And that is to have A as the source graphic, D as the destination bitplane, C as the copy, also the destination bitplane, and B as the mask. And the reason for this is that A and B can be shifted, whereas C and D cannot. So that means if you're going to have A as the graphic and B as the mask, and you need to shift both, as in this case, then you need to have them there. You could swap A and B, sure, but that would give a less optimal blit. It would take longer. It would not take more cycles necessarily to blit it, but it would be a longer time before the blitter was finished. That's a simple explanation. If you want more information, you can find my cheat sheet on my site, which has detailed information about the blitter that I've compiled. So C and D is easy because they don't need to be shifted. And you need, so to speak, a copy of the destination in order to combine graphics with the destination, because the destination channel is just a simple output channel. It's the result of the combination of A, B, and C. So the destination must therefore be in this among the sources for it to be combined with the source graphics and output. Wow, that was a very detailed explanation. Maybe not very necessary. We're gonna just write them down here. That's the cloud mask. destination Playfield and destination Playfield. So now that that's set up, we know how we want the sources to combine. I hesitate to show this in detail because, well, this will be changed. What we want to do is clear this and only set the destination to 1 where we want the destination to become 1 from the sources. If wherever the mask is 0, it would depend on the destination playfield data, right? So wherever B is 0, we should copy the C channel. So this applies and this applies. So this 0 comes then from the destination, this 1 comes from the destination, but not when the mask is set. When the mask is set, it should instead overwrite the destination with the source graphic. So in this case, if you're wondering why I went quiet just then, it's because I'm thinking whether I'm showing you the correct bits here. Tell you what, I'm going to give up on that and just wildly guess that my experience tells me correctly that the Minturn should be CA. So that would be like this. What does that tell us? That tells us basically that A is the mask. Ah, I see. Okay, so let's swap that around. Because the reason for having A as the mask and B as the cloud source graphic is because you have a mask register in the Blitter, which will let you mask the mask, and this will let you pick bobs easier. So this would give us, instead of this, it would give us 1100, 1010. That's going from bottom to top. And if we copy that, that's CA. All right. So we're going to copy this. Actually, this heading is incorrect now. Channel function. That's more like it. And grab that and go to our plot routine. This annoys me. So we know that we need to use all 4 sources, right? And we need to use this Minturn. Now I'm not going to mask the mask because I have the correct source mask. I have nothing. I have made sure to add a word at the right edge of each line, pixel line of the graphic, and that means I don't need this. So I can leave this as is. Otherwise, I would have to calculate this. And this would then allow you to pack the bobs tightly on the source bitmap, just as you would do for a game, for example, where you have lots and lots of bob graphics. that you have to fit and load from disk. So I'm happy with this, but now we're gonna have to set all the channel pointers, and I'm gonna try to make this dynamic. So I would make these point to the destination, which I will put in E1 for this routine. And this would be the source, and this odd register would be the mask. So we haven't yet included the mask, but we'll do that. Now, this will be removed because it's now dynamic, and we will test this with a fixed address and then calculate the destination address and the shift. The shift will go into this nibble here, the 0. But for now, we're going to test just blitting the bob on screen. It's always good to divide it into smaller steps, I think. We're also going to set the modulos for all the channels. And we want sky BPL minus cloud word width, right? I'm going to create a symbol for that. And the source will obviously have 0 as the modulo. And this is not very efficient, but it's very easy to read. So you might do a clear long word to BLTA mod, because in memory BLTB mod lies directly after BLTA mod. And we're going to calculate the size. The size would be 112, right? Cloud height 38. Cloud word width. Actually, we don't need that symbol. We can take the cloud width and divide it by 16. Now, we have to look out, because we know the width is an even multiple of 16, this is safe. Otherwise, you would have to make sure that you didn't supply an odd modulo here. So the size would be cloud width cloud height times 3 bit lanes, right? And we shift this 6 bits to the left and add the word width, which again is cloud width divided by 16. And I made a boo-boo. What I meant to say before was that this is the byte width of the source graphic that we are subtracting, and if that results in an odd number, then the modulo will be odd, and this will in turn by the blitter the last bit of the modulo will be ignored, so that your expectations would not be met simply. So let's do a recap, and also let's make a note of the registers so far. We'll expand on that later. Just having a once over. Correct minterm. No masking. Likewise, we will have to set this nibble to the shift of the B source later on. Next up is the pointers and the modulos, making sure that I've given all the correct custom register names. And this should be correct. And all we need to do to blit one bob is to do one blit. If you want, you could do it non-interleaved and do it with 3 smaller blits. This would let you do things like having some clouds be only 4 colors, for example, or only 2 colors to save on space for the graphics, or to just affect 1 or 2 bit planes instead of all 3. Things like that. So that's our plot cloud routine. I'm going to type the color code here. I'm going to do a quick calculation, something like 108 times sky byte width plus some horizontal add, something like 50 pixels, so 6 bytes perhaps, for the destination address. Now this will not look different from a copy operation once we're done. Just going to add it to the main loop, whatever it's called. Oh, we called it part 1 or something, didn't we? Gonna have a look. Yeah. Put bookmark. And if I recall correctly, we don't double buffer the sky. So that means that we may have to plot the clouds from top to bottom and make sure that the blitter is faster than the raster. We'll probably have to make it double buffered anyway, so we're adding this, so why not put it at the very end and see how that goes. What the hell? So that's our color code done. That's our symbols. That's our routine. That should work as soon as we add the cloud mask and the colors. We could keep the colors, I guess, but let's go to the copper and include our palette. Actually, I can show you a trick that I use, and that is to cloud.copper. That is to include a copper list or something else that I want to, if you want to search and replace within a selected block, that's not possible, at least not yet. But what you can do is we want to change these to start at 018, from 0180 to 0190, right? To make them set color 8 and up. So what you can do is include whatever you want to search and replace within. You can, actually I'm gonna just, long time since we saved. So what you can do is put it at the end of the source, make a global search and replace, like this. Oops. and then it will have only changed whatever's from the cursor and down to the end of the source. So just plop that in and remove the old palette, and that should be us done. Let's see how it goes. So I did call it masks, all right. And that's our cloud, all right. And it's in the correct position. Uh, it is 48 pixels from the left and 110, was it? 110 pixels from the top. So let's make this proper, and then we'll have a Bob plot routine that we can use to plot many clouds in the next episode. So what you would do is you would not use the source pointer here. Well, you could, because we're restoring all the registers, right? So we could modify A1 to whatever we want. So let's do that. But if you wanted to not save all the registers and save some CPU time, you would copy the source pointer into a working register and add to that. So we need two new parameters. That would be X and Y, right? And here's where we put them. Actually, all calculations sit better in front of the blit weight, because the blitter could be working and could have some cycles left over, and then your calculation would be ready in time for the next blit. So that's an optimization tip. That's our word offset, right? We want to double that to get the byte value to add to A1. Now this is not very optimized. Well, it's only a few cycles off optimized, but you could, if you wanted, you could add it already to A1 here. But I want to multiply the Y value. Why am I doing this? Yes. I make a copy of the X value because I need the X value later for the shift, right? And here we have to do an extend in order, just in case our bitmap is larger than 32K or 64K, then that means that the offset within the playfield will wrap around in if we used a word size value. So we need to extend this to long word, add it to D1, and that's our byte offset into the bit plane, just like the value we calculated with, sky b width times 110 plus 6. Just like that, we are doing it dynamically now. So we need this shift, so we still have it in D0. So we need to mask this with 15. You could do this. And there are various handy tricks to use for this, but for simplicity's sake, I will just roll this. I'm going to roll it to the right actually, and this will roll. Right now the shift is, I'm just going to type notes here. Let's say the shift for this X value is 0.4. After the roll, the value will be wrap around and be like this. So that's a trick for that. Now we can already put this in another register, and D2 is free, so why not use that? So we're going to clear that first. Clear the upper word of the long word because I want to change this. I'm going to move this. And at the end, I want to OR this to the final value. So what I want to do is, actually, I want to do this. I want to move the shift value, the wrapped around shift value, to D2. I want to swap that up into the higher word, right? And I want to move it again, make a copy for the B shift into the lower half of D2. And then I want to, you can OR or add or whatever you want, but we do need this minterm, so that's now our new complete blitcon 0 and blitcon 1 long word that we poke here. So that should be finished, but we have not yet supplied any values in D0 and D1. So if we comment this out and put, what was it, 48 in X and 108 in the Y register, that should do us, and we can't really comment this out, right? We have to keep this. It's good, it's handy to not give a random destination pointer to a blitter routine. So this now points to the top left corner of the playfield, and that's our X and Y values. Let's save here, and hopefully the cloud will both appear and appear in the same place as before. And I realize I've made an error, but yeah. So that wasn't correct. Was the X position correct, perhaps? Let's do some bug hunting. No, it was not. I'm getting D0 and D1 because we don't add it to A1. I forgot that. Shout in comments if you noticed before I did. That means you're a better coder than I am. No. It's a simple mistake. So we got the minterm in D2, and all we need to do is add this to A1. That should do us. We have one more error that I thought about. At least I think so. Let me think about that. So if I change the X value to give us, that puts it in the same place as before. So now I want to move it to align it to the left edge of the S in the sky logo. So I need to move it like 10 pixels right, and that should double check our shift routine. Boom. I'm just going to add 10 there. Yep. So that's the plot routine done for one cloud. See you in the next episode for more clouds. Thanks for watching.